Welcome, everybody. This is the Chapter 4 multiple choice packet. There's 26 questions here, and they all have their own story and in-depth context. So this might be a lengthy video, so feel free to move forward or backwards as you see fit. Um, but I'm going to take my time and try to be thorough. All right, so this first one is talking about someone who manufactures CDs. They want to determine if their cover design impacts and generates more sales. So the manufacturer chose 70 stores where the CD is sold, and then they randomly picked 35 of them to get the new design and 35 to get the other cover. So 35 of each randomly. They recorded the sales at the store and they found a significant difference between the average sold at each uh, type of store, each of the two groups of stores. Which of the following gives the conclusion? So um, A and B are both more or less saying it's not an experiment. There's no control group. So it's not reasonable to make a conclusion. But there was a control group, okay? It says they're testing out, um, where does it say here? The newly released CD. There are two different covers, okay? Um, So essentially, they have something to compare it to. The other cover represents the control. Um, each store is doing something different, so they can be compared to each other. So it is not A or B because of those reasons. It really is an experiment. A lot of people think of the control group as like a placebo effect, but in this case, that doesn't make any sense because you have to be selling the CD at both stores and it has to have a cover to be sold. C, it's not reasonable to conclude it was caused by the different cover designs because the 70 stores were not randomly chosen. The treatment must be randomly assigned, right? Meaning which cover each store should use should be random, but the stores themselves you can just pick. Um, it would be better if it was random, but it's far more important that the treatments themselves are randomly assigned than the stores that are selling the CDs, if that rings true for you. The right answer is next. It's D. It's reasonable to conclude the difference in sales was caused by the different cover designs because the designs were randomly assigned to the stores, like we talked about. That's good. Let's just chat about E because a lot of people choose E, but it says it's reasonable to conclude that there is a difference due to cover designs because the sample size was large. Well, large is, first of all, it's like, that's pretty vague. Like, what does that mean? Like, large enough? Uh, how large is large enough? There is not a minimum sample size. And it's not like I've said, well, your sample size is 30 or 40 or 50, you're good to go. Um, to know the minimum sample size takes in-depth analysis and actually requires having the data. And we don't have the data. Um, I know as the year goes on, I talk about having a large sample size, and that's important, but this is just a little too vague. It's just kind of, it's trying to trick you and have you pick that one. That ain't it. Two, dog food company is testing a high protein formula for puppy food. Um, they will be weighed when they are weaned and when they begin to eat. That's when they begin to eat the puppy food, and they'll be weighed a month later and a month later and a month later. The investigators wish to reduce variability due to natural differences in puppy growth rates. Which of the following strategies is most appropriate? So this natural differences comes up when you look down here. Geographic location is not a natural occurring difference. A natural occurring difference is dog breed, okay? So right away you can get rid of B and D. Where the dog lives is not a natural occurring thing, okay? So it's going to be A or C or E. And I've drawn um, flowcharts for what each of these looks like. Okay. Um, A says block on the dog breed and randomly assign puppies to existing and new formula groups within each breed. So that's like this. I just put like golden retriever, lab, poodle. Um, Within each breed, it says that some get the existing and some get the new. Within the lab puppies, some get the existing and some get the new, and so on. This is what you want. Um, okay, if you read carefully, C is not doing that. You stratify in dog breed, so it starts out the same way. But then what does it say? Assign puppies by breed to either the existing or the new formula. So that means more like this. The entire golden retrievers would be assigned to, in this case, I wrote existing, or the entire labs would be all assigned the new. That's not what you want. You want this, where you can say for golden retrievers, you have a control and a treatment. Okay, in this case, the existing would be the control. And the last one, E, it says assign puppies by gender to either the existing. So we're splitting on gender, which is a naturally occurring thing, right? So maybe you're thinking it's that one, but again, they assign puppies by gender. The entire gender gets either one formula or the other formula. That's not what you want. So the answer is A. Number three, a large simple random sample of people aged 19 to 30 living in the state of Colorado was surveyed to determine which of two MP3 players was preferred. To which of the following populations can the results of this survey be safely generalized? This one's maybe pretty intuitive, but the sample is a subset of the population, and it's a direct connection. So you can't all of a sudden say all people because you only surveyed people this age. Okay, so it can't be that. It can't be all people. Okay, it's got to be the people of this age group, and it's got to be the people in Colorado. If I ask people in Colorado what they believe, and I only ask Coloradoans, can I then say that can be representative of everybody in the United States? Okay. Um, you know, if this is my sample, it can only be projected out to everybody in Colorado of that age. So it is B. Okay. Part A is just kind of nonsense. It can only be generalized to the people in the survey. So that's not right. I mean, how limiting would that be if that was the case? Four, local TV news station includes a viewer survey question about the current issue. Viewers are invited to use social media to respond. The results of the survey are shared in relation to the opinions of the population of the region. Which of the following is a possible reason why the surveys could be biased? So number one says viewers with strong opinions are more likely to respond. Exactly, because you were invited. If you are passionate about this survey, you are going to volunteer. Okay, so that is definitely true. Okay, so you could eliminate B and C because that's one is true. You could eliminate D because one is true. So it's A or E. Moving on to two, the opinions of viewers of one television station are not necessarily representative of the population of the region. Um, um, hold on, I'm having a brain fart here. I think that, excuse me, that one may be fine as well. Yeah, I should put a check mark by that too. I wasn't. Uh, so exactly right. So like, in other words, the people that watch one particular channel in Minnesota, for example, do you think their views are necessarily representative of everybody in Minnesota? You know, um, you might have grandparents that watch a very slanted news reporting agency, that's on one side of the aisle or the other. Um, so you got to be careful there. So this is definitely true. Um, Okay, that takes just a little common sense. Like I have some family members that only watch extended family members that only watch Fox News, and then I have some family members that only watch CNN or CNBC and all these, and everyone has a slant. So that's going to introduce bias. Number three, viewers with access to social media are not necessarily representative of the population. That is also true because if you don't have access, that's under coverage. So the right answer is E, all three of them. Okay, could all three are reasons why it could be biased. Five, you're trying to here test and find the best way to cook a 5 pound cut of lamb in the oven. And there are two things going on. So you're going to cook it for either these lengths, okay? And you're going to cook it at two different temperatures. Um, so from 10 identical cuts of lamb, two are randomly selected to roast using each of the time temperature combinations in the same oven, okay? And the quality of the finished product is evaluated. Which of the following is true? The explanatory variable is the quality of the finished lamb. No, no, no. The quality of the lamb when you're done cooking it is the response. These, the time and the temperature, are the explanatory variable. Um, and part B, the response variable is the roasting temperature. Again, nope. That's the explanatory variable. So these two are being switched on you. C, if the experiment is repeated, identical results will be expected. No, no, no. Remember, sampling variability states that opposite results and varied states the opposite, that results will vary when you are taking random samples. So not C. D, there should be a control group, a one in which no treatment is given. Well, think about that. If you don't have a treatment, you don't have a temperature, and you don't have any minutes. In this case, that means you don't even cook the lamb. Yuck. E, the two cuts being roasted for each time temperature combination are an example of replication. Yep, two is more than one. More than two trials would definitely be preferred, but it is the minimum amount required. All right, E. Six. Uh, E is the answer. Number six. Oh, program exists to encourage middle school students to major in math and science when they go to college. The organizers of the program want to estimate the proportion of students who, after completing the program, go on to major in math or science in college. The organizers will select a sample of students from a list of all students who completed the program. Which of the following describes a stratified random sample? Which means you break the population into groups and then you randomly sample all of those groups. Um, so this is just, it's not breaking it into groups, just picking all the females. No. Randomly picking 50 kids on the list. No, they haven't been broken into groups. C, randomize the names on the list and get every 10th student. No, we're not putting them into groups. That's like a systematic approach. D is you are getting some female and then some male. So your groups, in this case, are male and female. And then from each group, you are randomly sampling 25. So it's D. E again is just there's no groups in E. Okay. 7. A randomized block design will be used in an experiment to compare two lotions that protect people from getting sunburned. Which of the following should guide the formation of the blocks? So when you block, you are blocking because you expect there to be different results between the groups that you're blocking on. Okay. Um, so which should guide the formation of it? Part A is not right. Participants in the same block should receive the same lotion? No. You're going to have different groups of people, and each group should have a control and the treatment. So they should randomly receive one of the lotions, not the same lotion. It's not A. Part B, the participants should be randomly assigned to the blocks. That's not true either. The blocks are decided on by the researcher because they have evidence or leanings that they matter. Maybe uh, the pigment in your skin, you're more likely to get burnt, for example, if you have more of it or less of it. So you're deliberately going to put people into groups based on that. Or maybe history of sunburns. So it's not B. C, participants should be kept blind as to which block they are in. Knowing what block you're in does not affect the results, okay? They still need to be blind to the treatment, but not to the block. Like I could say, if you know you are prone to sunburn and you've been sunburned a lot in the past, then that's fine that you know you're in that group. It's not a problem. D, participants within each block should be as similar as possible with respect to how easily they get sunburned. Ding, 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 there's the winner. E, just to learn from, participants within each block, within each group, should be as different as possible with respect to how easily they get sunburned. That's the opposite of part D, okay? 8, regional transportation authorities interested in estimating the mean number of minutes working adults in the region spend driving to work, commuting to work on a typical day. A random sample of working adults will be selected from each of the three strata: urban in the city, suburban, and rural in the country. Selected individuals will be asked the number of minutes they spend commuting to work. Why do we use stratification? Hmm. To remove bias when estimating the proportion of working adults living there. Well, so I put that's not even the goal. The goal is to under to estimate their commuting time. We're not estimating the proportion of them that live in these regions. That's not what we're learning. So it's not that one. This is also why D is not right. To decrease the variability in the estimates of the proportion of working adults that live in those areas. That's not what we're recording. That's not our goal. It's not A, it's not D. We are trying to get average time it takes people to get to work. B, to remove bias when estimating the mean, and C, to reduce bias when estimating the mean. um, Stratifying does not reduce or remove bias, okay? It's in this case, it's blocking. It is used because we suspect there's going to be differences among subgroups. If you live in the city, that's where a lot of the people work, your commutes are going to be shorter. So we suspect that. So we group you together. And then likewise, suburban and rural. So it doesn't remove or reduce bias. And remove, by the way, is just way too strongly worded. It's almost impossible to completely remove bias. So that means the answer is E. It decreases the variability in the estimates of the mean time. Um, so every group, if you put them together, the variability within the urban group will be much less. The standard deviation will be smaller if we put them into groups. Okay, they'll be more tightly grouped within each strata. Okay. 9. A researcher conducting a telephone survey is concerned about the possible source of bias. Of the following, which is the best example of non-response? And what that again means is people that you choose for the sample opt out. Um, A, B, and C. My note here that all of these are forms of response bias, and that is when it is it leads people to respond a certain way. It leads people to respond in a certain way. They might be uncomfortable with the question, and as a result, they don't answer truthfully. All of these are response bias. So that is not non-response. Non-response is when they send you the survey and you don't take it. So that is D. Okay. Many of the people selected to participate, that's them, do not respond, maybe because they have opinions different than those who do respond. Okay. It is that one. That's the winner. Star that one. E, Um, People without telephones are overlooked. That's undercoverage. So they're like they do often in this class. The other answers, the wrong answers, are just throwing other types, other definitions at you, and you're like, oh, I've heard that. That's true. These are true, these three. They're just response bias. And this is true. It's just undercoverage. It's not what they're asking you. 10. A researcher wanted to estimate the average amount of money spent on extracurricular activities per school in a certain region. They randomly selected 20 public schools and 20 private schools in the region. Sorry, got a cold. Which of the following best describes the type of sample that was taken? It's clearly not a census. That would be asking every school, so that did not happen. Um, it is a cluster sample. Sorry, it's not a cluster sample. Let me go through that ones. Is it a convenient sample? Doesn't seem that way. Convenient is, did they make this easy on themselves in any way? It doesn't seem that way. Is it a simple random sample? No. Simple random sample is where you might think it's this, but if you're controlling it that you have 20 of each, um, that's assuming are there an even amount of public and private schools? If there's not, then this is not going to be representative of the entire population, and an SRS is representative of the entire population. Um, another way to say this is um, doing it this way is controlling the sample in a way that it does not allow for any possible combination of public and private schools when you randomly sample. Like you could have a sample that randomly had 19 of these and 21 of those, and so on. But we're not even allowing for those samples to be eligible. Okay? And that's not good. So that's why it's not a simple random sample, which is this is what we want. It just isn't that. So stratified here and cluster. The difference again is stratified is when you have your groups and then you randomly sample some of each. Okay. Cluster is when you have your groups, public and private, but then you pick a group and pick everyone in one of these groups. So a cluster would be you got your groups and then you would pick all the public schools, all of them, and you'd pick none of the private. That's what cluster would look like. So it's not a cluster, and it's not that, it's not that, it's not that. It is E. Okay. 11. A school principal wanted to investigate student opinion about the food served in the school cafeteria. The principal selected random samples of 50 first-year students, 50 second-year, third-year, and fourth-year students to complete the questionnaire. Which of the following best describes the principal sampling plan? Well, we just kind of went over that. You have groups that you're taking 50 from each group. It's a random sample of each group. Stratified is like a group. Okay, enough on that one. 12. Survey was administered to high school parents of high school students in a certain state to see if the parents thought the students' academic needs were met. To select the sample, the parents were divided into two groups. One group of parents who lived in the cities with populations more than 100,000, and other groups of parents who live in smaller cities of less than 100,000 people. A random sample of 100 parents from each group was taken. Which of the following statements about the 200 parents is true? This is another one. It's a stratified random sample, right? You've got two groups of people, the large cities and the small cities, and you're randomly sampling some of them, 100 of each of them. Okay? It's not very convenient. It seems like a lot of work. It's not a cluster. A cluster would be if you split them up into the large cities and small cities, and then you picked one of those two, say small cities, and you asked everybody in the small cities group, which would be really not a great idea, especially when there's only two groups. Um, is it a random cluster sample? It's not a cluster sample. because groups of high schools were randomly selected. No. Sorry. E, it's not systematic. Systematic would be like if you um, had all the parents into one large list and you surveyed every 10th parent. That's what they mean by systematically. All right. 13, a well-designed experiment should have which of the following? It needs all of these. Remember, CRR. It needs control, it needs replication, and it needs to be random. CRR. 14, an experiment will be conducted to determine whether children learn their multiplication facts better by practicing with flashcards. Children who volunteer for the experiment will be randomly assigned, that's good, to one of two treatments. Because the children's gender may affect the outcome, there will be blocking by gender. So they're either going to use flashcards or a computer. After practice, the children will be given the test on their multiplication facts. Why is it impossible to conduct a double-blind experiment? Well, what's double-blind? It's this. It's when the researchers and the kids, the subjects, don't know what treatment they're getting. Well, that leads us straight to C, you guys. The kids know what is happening to them. Hey, kids, use these flashcards. Hey, kids, use the computer. So they know. The researchers might be blind to it. You could have that, but you definitely cannot have this. So it's C. Okay. 15. As part of a study on facility needs, the administrators of a university wanted to estimate the percent of students who use the exercise facilities on a regular basis from 34,000 students who attended the university. A random sample of this many males, this many females, so the total sample was 770 students. Of them, 493 indicated that they use the exercise facilities on a regular basis. What are the population and the sample? So the population, you guys, is the university. It's all the kids, all of them, right? It's not the sample, so it's not A or B, so it's one of these three. And then the sample is these are all distractions, right? It's not males, it's not females, it's not how many said they used the gym. It's everybody that they asked. So that is D. 16, a large conference of teachers from a variety of subjects. At the large conference, they randomly sampled 50 math teachers, even though here there was a variety of subjects there at the conference. Among the selected math teachers, 28% had taken one or more courses in statistics. For which of the following population is 28% a reasonable estimate for the percentage of those who have taken one or more courses? This is really just getting you again to know that your sample is a subset within your larger population, but don't change the characteristics, okay? You've got math teachers that you're sampling, so you can only project that onto math teachers. You can't sample math teachers and then project that onto like English teachers and other subjects. Why in the world would that make any sense? So the population is all math teachers who attended the conference. Okay? It's not all math teachers in the entire world, okay? Because these math teachers are a subset of people at the conference. Okay. Yes, there you go. 17, each person in a SRS of 2,000 received a survey and 317 people returned their survey. How could non-response cause the results? Remember what non-response is? This is when you are given the survey and you opt out. Okay. This says those who responded did not respond reduce the sample size? Nope. The sample size is still 2,000. It doesn't change. It's regardless of who, writes back or submits their answer. Okay. But again, this is trying to just distract you. You're like, oh yeah, small samples have more bias. Yeah. Which is a reasonable statement, but it doesn't change the sample size. Those who didn't respond caused the violation of the assumption of independence. No, they just didn't answer. Okay, not that. Those who did not respond were indistinguishable from those who did not receive the survey. Um, no. They were part of the sample, so they are distinguishable. Okay. D, those who did not respond represent a group or a stratum, changing the simple random sample into a stratified random sample. No, the results of a sampling method don't change the method that we're using. It was not given to different groups. It was given to just one group, one sample. Okay, so just because they didn't respond doesn't make it all of a sudden a stratified grouping. So it's E. Those who didn't respond may feel different in some important way. And again, this is they may. So this is risky, okay? They might feel strongly about the topic as a group, and their responses will not be taken into account. So that is the bias. 18, a poll of 1,500 randomly selected eligible voters. Only 525, 35% of them, said they did not vote in the last election. However, a vote count showed 80% of the eligible voters actually did not vote. Which of the following types of bias is most likely to have occurred? Non-response is when they don't reply to the survey, and we have no information on this. It does not tell me how many people responded, so it's not that. Sampling bias is just way too vague, folks. You want to pick out one of the specific name titles, so probably A, D, or E. And selection bias as well. It's not selection because it was random, so it's not that, not that. It's response bias because this again is people feel influenced to answer a certain way. You know, a lot of people think voting is your civic duty. It's something we all should be doing. And so if I ask you, did you vote a week or two ago and you didn't, you're going to be like, you might be influenced to lie. Undercoverage would be that they they left out a group of people that had no chance to be in the sample. It doesn't suggest that in any way up here. That would be like they gave the survey to people they found in the phone book. And it doesn't say anything like that. Okay. All right. 19. In the design of a survey, which of the following best explains how to minimize response bias? Okay, again, response bias is often called wording bias. It's leading them to answer a certain way. So this this is doing these things will not change the fact that there's response bias. Making the sample larger won't change the fact that it's worded poorly. Making the sample smaller won't do that. Randomly selecting the sample won't change the wording bias. Increasing the number of questions, if they're worded poorly, doesn't change this. So it's E. You need to carefully word and field test the questions. 20. Staff members of the high school newspaper want to obtain an estimate of the average number of years teachers in the state have been teaching. At an educational conference attended by many teachers in the state, the staff members randomly pick 50 conference attendees, and ask them how long they've been teaching. Which of the following describes the sample and the population of which it would be most reasonable to generalize the results? So the teachers in the state, okay, is the population, okay? And the population is all the teachers in the state. So right there, you could limit it to this one or to this one. All right. And the sample is the people they actually asked. So here it says all conference attendees, so you can get rid of C. That might be enough for you to get it, but just in case. The sample is the 50 conference attendees. That's good. And the population is all conference attendees? No. Um, Again, the population is usually referred to as who are they trying to learn about? They want to obtain an estimate of the average number of what? Years teachers in the state have been teaching, not teachers in the conference. So it's A. E, just to touch on, The sample is the average number of years that all conference attendees have taught. No, this is the result of the sample. The the sample is the people that or the subjects that they're asking the question. 21. You have people at an electronics store want to estimate the proportion of defective wireless game controllers in a shipment of 5,000 controllers from the supplier. The shipment consists of 200 boxes each, and each box has 25 controllers, which makes 5,000 controllers. The buyer numbers the boxes 1 to 200 and randomly selects 6 numbers in that range. So, in other words, they're picking 6 boxes, okay? And then you open the 6 boxes and examine all 25 controllers in each of the boxes. That is the definition of a cluster. Select a group. In other words, in this case, select a box, and it's random. It said it was random. And you could have more than one group, and they did. They had 6 groups, and then select all the items in that group. So that's E. 22. You have a fitness center. They want to examine 2 exercise classes, a spinning class, that's like a bicycle class, and aerobics, and the effects they have on body fat percentage. A 6-week spinning class and 6-week aerobic class are offered at the same time on the same days so that a person can enroll in only one of them. A new class is about to begin, and each class has 25 people in it. 10 people are randomly selected from each class. Each person's body fat is measured at the beginning and at the end of the 6-week class. Using change in body fat as the response variable and conducting a test at the alpha equals 0.01 level. We'll talk about that later, what that means. The director determines there is a significant difference between the treatment averages. Which of the following is a confounding variable? These are variables that may affect the body fat percentage, the results that are not being measured or controlled. And here it is, well, let's just look. The director's choice of spinning and aerobics classes are the types. That is being controlled, very, very much so. Those are the 2 options, right? We're looking for things that are not being controlled. Um, the part B says the random sample of 10 people from each class. That's good. You want it to be random. That's controlled. That's good. Here it is here. The participants are choosing what class to take. Does the researcher have control over that? No. Okay. And think about it. Um, if you think the cycling class is too hard and you're like, yeah, I'm going to do the aerobic class, your motive introduces bias. Maybe word gets out that the cycling class is much harder than the aerobics class, and everyone just, by and large, and the majorities take the easy class. Well, that's going to be an underlying confounding factor of motivation and desire, which will clearly impact their results. Okay. Using body fat percentage as the measurement, that's fine. It's the chosen metric, and that's what's being measured. That's not a lurking or hidden variable. And E, the fact that both classes were conducted 3 times a week at the same time of day, at the same um, and for the same amount of time. That's good. That eliminates time as a factor. That's good. Um, 23. Student government at a high school wants to conduct a survey of student opinion. It wants to begin with a simple random sample of 60 kids. Which of the following survey methods will produce a simple random sample? So as soon as I read this, I'm looking at these, looking for which one does every kid have a chance, an equal chance, to be randomly selected. It's not this one, because that's convenient. If I'm not an early bird and I'm not one of the first kids to get to school, I don't have a chance. This one is systematic, and some of you might think this is it. You get every 10th kid until 60 kids are surveyed. This system, once you determine every 10th person, you are kind of, well, that is random. You're kind of eliminating everyone that's not the 10th person. And also there's a little bit of convenience to this. Again, if you are one of the last kids to show up at school and they've already collected their 60 kids, you don't have the chance eliminates the chance for late arrivers. Um, C, using random numbers to choose 15 first year, second year, third year, fourth year. That is stratified. You might be like, yes, but stratified is not a perfect, simple random sample. It eliminates random samples with uneven numbers from each grade, and that is not good. What if the the grades don't have the same amount of kids? D, number the cafeteria seats and use a random number to choose the seats and interview students until 60 have been interviewed. The only problem is, what about kids that don't eat in the cafeteria? Um, or what if they were sick that day or something like that? But especially, there's a lot of kids here, they don't eat in the cafeteria, or maybe they go to their teacher's room for that hour or that lunch period. That's under coverage. And E is the one, okay? You have an official school roster. This already sounds great. We did this in our class with when we picked out who has the long putter and who has the short putter. And then we used a table of random numbers, okay, to pick the kids. Every kid has an equal chance to be in the sample. 24, to check the effect of cold temperatures on the elasticity of two rubber bands, two brands. You have a box of brand A and brand B. The 10 bands from brand A are put in the freezer for 2 hours, and 10 bands from brand B are kept at room temperature. Okay, and then they record the amount of stretch before they break on each rubber band. And they get the average or the mean for the cold bands and compare it to the average or the mean for the warm bands. Is this a good experimental design? No, it's not. Okay. What you want is you want to block, you have um, you have brand A, you have brand B, okay? And you're essentially blocking on these two because you think there's going to be a difference. Block on brand. And then within each group, you should have some cold and some warm. And you should randomly assign, okay? Same thing here and here. Some get cold, some get warm. And this is not what they did, okay? They gave all of brand A, what, the warm ones, was it? Oh, wait, brand A got all the cold ones, and brand B got all the warm ones. That doesn't allow for comparison here, right? You want to compare here, warm to cold within each brand. So let's go through some of the reasons why. It says no, because means are not a proper statistic for comparison. Sure, they are. The average length of rubber band stretches before it snaps. That's fine. Nothing's wrong with that. No, because more than two brands should be used. That's determined by the researchers' goals, okay, not some universal standard. Um, More brands or more temperatures, okay, both those, that's not true. D, because temperature is confounded with brand. Exactly right. They're not really controlling the brand and the temperature, like I was explaining earlier. There should be 4 treatments. Brand A gets both, brand B gets both, okay, to eliminate that confounding. An easy yes, love it. If you ever just see yes with no explanation, please, for the love, please do not pick that option. 25. Which of the following can be used to show a cause and effect relationship? To be a cause and effect, it's got to be an experiment, okay? It has to have a control group. A census has no control group. An observational study doesn't. Survey, no. Okay, those are all observational. 26. Which of the following distinguishes observation from randomized experiment? Um, in an observational study, volunteers are always used. Whereas in a randomized experiment, a random sample is taken from the population. uh, Observational studies don't have to be voluntary. Okay? Excuse me. They don't have to be voluntary. All right? Part B. In an observational study, a random sample is always taken from the population. Not necessarily. Okay? Whereas in an experiment, volunteers are always used. Just in general, folks, when you see these words always, you should just get freaked out and almost never pick those, okay? C, in an observational study, treatments are not assigned. That is true. In fact, and maybe the randomly throws you off. Just think of it better. Like they are not assigned, period, right? There are no treatments, which is true. Whereas in a randomized experiment, treatments are randomly assigned. So that is the one, that's the winner, okay? What's wrong with D and E, just to sum this up and put a ribbon on this? In an observational study, a control group is never used. Okay, well, iPads just died. AirPods just died. You might not be able to hear this. Whereas in a randomized experiment, a control group is always used. Okay, there's that word never again. Run away! E. An observation can be double blind. Double blind is only relevant when you are assigning treatments. And observations do not assign treatments, so it's not E. All right, folks. I don't know if you can hear these last two, but there you go.